Okay, let's do some R examples to see how to use this Box-Cox and power transform with R. Well, the first example we have is from the book ISLR. So you just do attach the library ISLR and also attach the dataset, auto dataset. Originally we fit a model with we regress this MPG on house power and do a scatter plot of this our Y MPG and our X house power. And this is what it looks like with our original model or originally regression line. The next, I'm showing you this what it looks like originally for the standardized residual versus our X house power. Looks like there is a non-constant variance issue here. Let's see if we use the Box-Cox function, what it looks like. So again, this Box-Cox function is from this mass package. So you attach this mass package first and directly do a Box-Cox onto our linear regression model. So this all2 underscore LM is our linear model. Here, all2 underscore LM. So directly work on this and it will give you this like log likelihood method to estimate this lambda and also give you a 95% confidence interval for this lambda, lambda hat, the optimal lambda value estimated from this Box-Cox. I'll show you how to find this lambda with R coding. So again, so I assign this Box-Cox function results to this BC trans Box-Cox transformation. So this which dot max of this Y value in our BC inner score trace will give you the maximized value. If we're trying to find which of the like this is trying to find our lambda value. So this one will give you the precision of the precision in this BC trace $y. So this is a 39th position in this BC trace trans and $x. This is all the lambda values. So we find the position which makes this Y maximum is the 39th element. So we just extract that 39th element from this vector, which is our optimal lambda value, lambda hat. So we just run this lambda to be -0.5. Now we are going to make our new data, the transformed data, being this MPG to the power of lambda -1 over lambda. And we do a new LM with our transformed MPG and also plotted, plot or scatter plot, and also attach the regression line, which looks better comparing to this untransformed MPG. So this is with our new MPG. This is our originally what the model looks like. So this one looks better compared to this one because the data are more like close to this regression line and they are like evenly distributed around this regression line. But this one is kind of having a curved shape. So it's not that close to this straight line. So this Box-Cox transformation seems working for us. Okay, let's again look at let's look at the residual, the standardized residual. This is, I plotted the standard R standard. This is the residual, standard residual from this linear model. So I plotted, this is for the transformed MPG. This is what it looks like. Comparing to previously, when we have this original MPG untransformed, I also did this residual, standardized residual, and this one was showing us a trend and also non-constant variance for the residuals. So this transformation does work to stabilize the variance and help us remove some of the trend as well. Oops, sorry. I'm trying to enlarge it a bit. Okay. Well, this is the Box-Cox transformation example. Another example will show you how to use this power transform, but we are doing a transform on the predictor variable x. We'll use the modified BC data, which is also from this RSLR library. So once we attach this library, we can directly work on this. So again, we show you the original model. This is what it looks like. And this is what the residual plot, standardized residual looks like. Now we do a transformation on X. So previously we did the transformation on Y. Now we do the same thing for X, but we use this power transform function. Let's see what it suggests us to do. Well, this function power transform is from the library car, so you have to attach this package first. We can, like this house power is our, this house power is our X variable, our predictor. So we just directly do a power transform for this variable because we have attached this auto data set, so we can call this variable directly instead of use a $sign with that auto data set name. Yeah, so we do a power transform on this X directly and do a summary and see what it tells us. So this is Box-Cox power transform to normality, and it tells us the estimated power rounded, which is negative 0.4532. Well, this is the estimated power lambda, and this is rounded power, rounded lambda. And it can also give you the lower bound and upper bound for this estimated lambda. And also it gives you two likelihood ratio tests on lambda equal to 0 or lambda equal to 1. And it shows you the p-value, like we rejected the null hypothesis that lambda being 0 or lambda being 1. We reject those hypotheses quite strongly. Anyway, this power transform suggests us to do negative 0.5 transformation as well. So now let's do this transformation. Just raise the data to the power of negative 0.5. So let's use this function directly instead of like manually do the transformation. So this is how horse transformed, being this BC power working on this house power, and this is the lambda we have estimated. from this function. So this is horsepower rounded lambda. So now we have this transformed x value. Now we plot our y versus the transformed x. Well, again, this linear regression line looks better to this transformed data, but it's not as good because you can actually tell the variance is not really constant. I mean, across the data. Well, if we look at the standardized residual versus our transformed x value, we can also tell a little bit. There is like this funnel shape, which means not very stable variance for the error. Well, in this case, we tried to transform y, which gave us valid results, and also transform x. Well, the result is not as good as we only transform y. So in this case, I will stick with the previous one, like we only transform the y variable, but not the x variable. And also, like I showed you how to like manually do this. Oh, by the way, I mentioned like this transformation will switch the relationship. But we can like get it back by just doing this, plot this MPG versus like this is our y value and this is our x value. Well, we use this I here when we have this like power function in R. Like if you do something to the power of 2 or 3, well, you have to have this I with this bracket in order to make it work like for our code. So this is something to notice. So this is what it's like. If we like transform manually do the Box-Cox transformation on the scaled power transformation, it will be like this. But they are just kind of equivalent model, but this is just different way of presenting them. Eventually, I detach this auto data set like after finish working on this project or this data set. It's a good practice to detach it when you finish.